Okay, welcome to the video. This is the first video in the linear algebra and modeling sequence. This is called vectorized functions. We're going to start here with Algebra 1. Hopefully everyone remembers their Algebra 1 course, and from that course we're going to start with the slope-intercept equation, which is this equation right here, y equals mx plus b. It's called the slope-intercept equation because the coefficients here are the slope, so the m is the slope, and the b is the intercept. So if you have both of those, then you have it fully defined, a linear equation with a slope and a y-intercept. So a function of this form actually defines a relationship between the two variables, x and y. You can think of it as a mapping from x to y, or as the function f of x equals y. So for any x value, you're going to have a unique y value. And we can use R, our chosen programming language, to model a linear function like this one in two variables. Now, I use the word model here because in a mathematical function in a computer is by necessity a model. We typically think of functions when we think of them in the abstract sense, like in a math class, we think of them as being continuous. So, if you had some function here, you could pick any 2 points on that function, and in between those 2 points, find another point. And in between those 2 points, find another point, and so on and so forth. We have the property of infinite smallness. And that's just not the case in a computer. At some level, the computer is not going to be able to represent the value in between 2 points. We're actually going to have more of discrete valued points representing the function. So it's a model to the actual function. And just a quick comment on nomenclature that we're going to be working with. I'm going to use the name xx for a vector of x values and yy for a vector of y values. If I'm referring to a single value, I'll just call it x or y, but if it's xx, that represents a vector of values. So here I've got a vector of values that I'm working with. So I just assigned to xx the sequence from 1 to 10. Which R has this nice shorthand with the colon to be able to generate for us. And I can display those values. Here they are, the values from 1 to 10. And so xx is a vector of these values. It's all 10 of them. And then we might think about the slope in this particular slope-intercept equation where the slope, m, is 0.1 and the b is 1. So this means that this line has a slope of 0.1. So for each run of 1, it rises 0.1. And it crosses the y-axis at y equals 1. So the y-intercept is 1. And we can generate a y vector of y values by doing just simple vector arithmetic. So I'm going to multiply 0.1 to each value in xx and then add 1. And here is that vector, and you can see that it goes from 1.1 to 2, incrementing by 0.1 each time. So the last thing I'm going to do in this notebook is actually display the vector functions, the vectorized function, with a plot of xx versus yy. And I actually want to set some options with regard to that plot. In particular, I want to have a certain width and height for the plot that I'm going to generate. So I'm going to use the R library repr to do that. So I've imported the library repr right here, and then I define some options with it down here. Okay, and then finally, I am going to plot the function, and you can see that I set some options in my plot. I set a y-lim and an x-lim, and what that has is that has the effect of defining the windows that we're going to be looking at for the plot. So the repr set the width of the plot as it's displayed or as it's generated. But these options here set the window into which we're going to be seeing, like this area here. And the last thing that I do is I add two AB lines. I add one at, I add a horizontal line at y equals 0. So that's this line right here, and a vertical line at, a horizontal line at x equals 0 and a vertical line at y equals 0. The correct way of saying that. Let me clear that out. And we can see this plot that we've generated here. And we've just plotted each of the points in that we have the vector of xx and yy. We plotted them against each other. And you can probably use your imagination to fill in the lines to generate a line there. But this actually goes to my earlier point of it being a discrete valued function. We can intuit that these points are also on the line, but R does not know that without us explicitly telling it.